In the last video, we laid out almost all the components of the GamePad that we need. But we're stuck in a situation where we need to place the OLED module, but KiCad doesn't have a symbol or a footprint for it. So in this video, we'll create a custom symbol for the OLED module and add it to the circuit. But before we do that, go to the Arduino and create two wires for pins A4 and A5. Make them a bit longer than the other wires to the left. Now open up the labels menu and give pin A5 the label SCL and pin A4 the label SDA. Place these labels in the middle of the wire instead of the end, leaving the end of the wire open. We're doing this as a favor to ourselves. The Arduino has a built-in hardware I2C controller that connects through pins A4 and A5. However, notice the symbol for the Arduino doesn't show which pin is which. So if the pins are accidentally reversed, the I2C controller won't be usable. This is something that has bitten me personally a few times in the past, so by adding these labels, we can create another layer of protection during the design process. Now that these wires and labels are done, go back to the KiCad main project window, and then click on the symbol editor icon. A new window will pop up, and in here we'll create our new module. First, go up to File and select New Library. You'll be presented with two options, Global or Project. Which option you choose determines where we want our symbol to exist. Choose the global table if you plan to reuse this part in future projects down the line, or leave it as project to make the symbol library only exist for this project. But even if you make the part project local, you can still reuse it in other projects by copying the library folder manually to a different project. For now, let's choose the project table and make it local to this project. Name this library OLED_module. The left-hand panel shows all the libraries that are loaded into KiCad. Scroll down until you see the OLED module library and then right-click on it and select New Symbol. A new symbol window will appear where we'll start defining our new symbol. For the symbol name field, give it the name I2C_OLED_module. Then leave all the rest of the settings as default and press OK. What you'll see now is a large letter U inside of what looks like a blank schematic. So zoom out with the mouse wheel and we'll start laying out our new symbol. On the right-hand toolbar, click this icon to add a rectangle. Don't worry too much about getting it the exact size you want. It can always be changed later. Now, before we do anything else, we need to take a good look at the screen module itself. Specifically, we need to make note of the correct pinout for the module. Virtually all the I2C OLED modules have the same pinout. Starting from the left, it should go ground, VCC, clock, and then data. Let's say for the rest of this project that the ground pin is the first pin. Then VCC would be pin 2, clock would be pin 3, and data would be pin 4. If you want to use a different pin order, that's okay, but you absolutely must keep this pin order consistent throughout the entire project. Otherwise, who knows what order the pins will take in the end. On the right-hand toolbar, click on this icon to add a pin. This will open the pin properties menu. At a minimum, we need to define at least 3 of these options for each pin we make: the pin name, the pin number, and the electrical type. Pin name can just be the same label as the pin on the module itself. So I'll make this one GND for ground, which has a pin number of 1. And finally, because this is a power pin for a device that's receiving power, we should set the electrical type to power input. Stick this pin at the bottom of the rectangle facing down. Now repeat these steps for the VCC pin, which is also a power pin that has the pin number of 2. This pin should go at the top of the rectangle. And just for future note, it's good industry practice to make the power always facing up and the ground always facing down. Now we'll add the remaining 2 pins. For the clock, this will have the electrical type input, and data will have the electrical type bidirectional. Stick these 2 pins on the side of the rectangle. Now go up to the menu bar, click File, and then Save. And with that, we have now created the symbol for our OLED module. Go back to the main schematic page and open up the parts menu. Search for the OLED module we just made and then add it to the schematic. Wire up the power inputs to the 5V and ground power labels. Then connect the clock and data lines to their respective pins on the Arduino. Now we're ready to start finishing up our schematic. First, go up to the top toolbar and click on this icon. This will open up the electrical rules checker. Now click on Run ERC. You're going to see a whole bunch of warnings come up, but don't panic, this is normal. Most of these warnings are just because many of the pins on the Arduino aren't actually connected to anything yet. So to fix that, we just need to use our non-connected tool and start marking all the unused pins. Once done, run the ERC again. You may have a warning come up. For example, my ERC is telling me that one of my wires isn't connected on the 555 circuit. If I go down there, I can see that at some point I must have deleted the wire connecting the threshold and trigger pins to the capacitor. You might have to fix a problem that your schematic has, but it should be fairly straightforward. And eventually, when you run the ERC, there shouldn't be any warnings. There are still some housekeeping things we can do. For example, we could scale the schematic back down to the A4 size by rearranging some of these components, which would make the schematic more printer friendly. We should also go into the page settings and set the date field for the schematic. One thing we should also do is give our custom part a visible name. To do that, go back to the symbol editor window. Find our module part in the library and open it. Then go to File and select Symbol Properties. In the Value field, enter in I2C OLED module, and then press OK. Save the part and then go back to the schematic editor. Now right-click on the module placed on our schematic and select Update Symbol. When the Update window opens, make sure to check the Value checkbox, and then click Update, and you'll see that our custom part now has a name attached to it. And at this point, we're done laying out our schematic, which means we're almost ready to start laying out the PCB. But before we can even place a single part, we first need to tell KiCad what parts we want to use. The machinery that creates the PCBs needs to know where to drill the holes for the parts. And the only way we can figure that out is to start matching our symbols to real-life parts. So in the next video, we'll start choosing our parts from a distributor and assigning our symbols footprints.